The final type of equation that we need to review is when there's the variable on both sides of the equation. So let's say if we have three, just to make this as simple, let's say we've got 3 boxes on one side of a seesaw. And we've got a box and, I don't know, 8 on the other. What is the worth of one box? So box equals what? Well, if I want to keep things in balance, I need to get a better sense of what the 8 has to do with things. I can take away one box from this side if I also take away one box from this side. What that tells me is that 2 boxes are equal to 8. So if 2 boxes are equal to 8, then each one must be 4. A box equals 4. Looking at that, if I wanted to translate that into algebra, it would be 3x is equal to x plus 8. In keeping with everything we've always talked about, we're trying to isolate the variable on one side of the equation. In this situation, you can see there's variables on both sides of the equation, and we need to get rid of them. We need to first get them all on one side of the equation before we can solve. So just like if I wanted to act out what happened on the seesaw, I'm going to subtract x from this side. If I do it to one side, I also do it to the other. I always have to bring my equal sign straight down. This means that 2x is equal to 8. Oops, 2x is equal to plain old 8. And what that means is when I divide both sides by 2, I find out that x is equal to 4. That leads me to the 2 big ideas, really, this 2 steps. What we're trying to do is get the variables on one side the constants on the other, constants meaning numbers, and we do this by adding the opposite. And after I've done that, all I have to do is solve. So let's do a bunch of equations and see how this plays out. Very similar to the one that we did in our example. If I have 3y is equal to 15 minus 2y, once again I've got variables here and here. I want them all on one side of the equation. So since I want them on the side of the equation that doesn't have constants, I will add 2y to both sides. And I can see that 5y is equal to 15, which makes 1y equal to 3. Notice it's very important to always bring your equal sign straight down. 2 things that kids sometimes get mixed up is they think, well, why can't I combine my like terms, 3y and 2y? And that's because they are on opposite sides of this great wall of equal sign. A really common mistake that kids make is they say 3y is equal to 15 minus 2y. Okay, well, I need all my variables together. I'm going to add the opposite. Okay, that means I must have 15 is equal to negative 5y. But if you see what happened, this is wrong, because 3y minus 3y is actually 0, and what you've done is move the equal sign. That is really, now, it should be 15 minus 5y, and if I continued from there, I could get the right answer. So, rule number 1, just a reminder, don't move the equal sign. It can be a problem. Okay, on to some. How about the equation well, let's do 5x minus 9 is equal to 2x plus 12. Notice on this one, now I've got variables on both sides and numbers on both sides. Personally, I mean, you can go either way. You can bring your variables to one side and your constants to the other. I like to do it so that my variables end up with a positive coefficient. In this problem, that means I would subtract 2x from both sides, making it positive 3x minus 9 is 12. And then I would add 9 to both sides because my constants went to the left. My variables went to the left, my constants will go to the right. That makes this 3x is equal to 21. And that means that x is equal to 7. Notice, I could have done the exact same thing going the other direction. I'm going to just erase all this and show you what it would have looked like if I brought my variables to the other side and my constants. And plus, you can also do this all in one step. So that's what I'm going to show you right now. If I want to bring my variables from left to right, I have to subtract 5x from both sides. And I then would add 9 to both sides. What did I do? I did exactly the wrong thing, just like what I told you not to do. If my variables are going that way, then my constants have to go that way. So if I'm subtracting 5x this way, I'm bringing my 12 over here. If I do it like this, the constants will cancel out on one side and the variables on the other, which is how I recognized immediately that I had made a mistake. Negative 21 is equal to negative 3x. And voila, toi, I get the exact same answer. The moral of the story is keep your equal sign steady and bring your variables one direction and then bring your constants the other. It doesn't matter which way you choose to go. So let's look at some ones that have some fractions in them. If I say 4/5 of x plus 3 is equal to x. Well, hopefully by now we've gotten comfortable with the idea of the fraction destroyer, meaning if I multiply the entire equation by this 5, I can then destroy this fraction, giving me 4x, but every term also needs to be multiplied. There's no protective shield here, so 4x plus 15 is equal to 5x. Now I need to get my variables on one side of the equation. There's constants only on one, variables on two, so that means we want to bring our variables that way, meaning 15 is equal to x. And that's the answer to that problem. Sometimes you can have problems that involve fractions that look like this. 8 plus x is equal to 9. Divided by 9 is equal to x. This entire expression is being divided by 9. In fact, the fraction bar really is a kind of grouping symbol, so I can't really touch that. That is more or less in its protective shield. I know the 9, if I multiply by 9, it will destroy this fraction. I also need to multiply the other side by 9, so that gives me 8 plus x is equal to 9x. Notice I have variables on both sides. Don't want that. Need to bring this variable over here by adding the opposite. That means I'm subtracting 1x, because adding a negative x is the same thing as subtracting an x. So 8 is equal to 8x. And all of that leads us to the fact that x is equal to 1. Okay, one last example that has everything that we have been working on in our review. 7, well, except no fractions, 7 times x minus 2 minus 6 equals 2x plus 8 plus x. with the idea of sides of the equation in mind. Here's one side of the equation, here's another side of the equation. Before I can even get to the point of bringing the variables to one side and the constants to the other, I have to first simplify each side. So on the left side of the equation, that means doing the distributive property, and then combining these like terms. So on the left side, it simplifies to 7x minus 20. On the right side, all I have are the two like terms, and that gives me 3x plus 8. Okay, now I'm ready to get my variables on one side of the equation and my constants on the other, keeping in mind, here's my wall. I get this, I accomplish this by adding the opposite. If I bring these, if I take away 3x from both sides, my coefficient to the variable will be positive, and as I said before, positive numbers are good. Not the only way to do it, but this is how I would try to do it. I know I've done the right thing because the constants cancel out on one side, the variables on the other. This leaves me, and by the way, if you prefer to do it on 2 steps, that's fine too. 4x is equal to 28. I'm saying 8 and writing 7. When I divide by 4, I find out that x equals 7. So, in addition to this in tonight's homework, and this is a review from before, moving on to some trickier word problems. If you could look in your text at page 119, problem number 8, you will see a tricky consecutive integer problem similar to this will be on your next test. And I'm going to write it out. The greater of two consecutive even integers. Right away, as soon as you hear the words consecutive even integers, your mind should be going to, okay, how do I assign those variables? Integers is 20 more than twice the smaller. Find the integers. What's different about this is they aren't just giving us a problem where it says the two consecutive integers add up to something or the other. Right now it's a little more complicated. We have to actually think about how to translate this into an equation. What is the same is I'm going to assign variables the same way. I have two consecutive even integers. Notice, though, that they're calling them greater and smaller instead of first and second. So I think that when it comes time to translate, it's easier to use the words of the problem. So I'm going to call them the smaller and the greater. But that doesn't change the fact that if I have an even integer, one even integer, the next consecutive even integer is 2 more than the first. So if one of them is x, the next is x plus 2. Now, let's go back and look at the words and translate. The greater of two consecutive even integers. Well, what are we calling the greater of two consecutive integers? Translate into x plus 2. Is almost always means equals. 20 more than twice the smaller. 20 more than twice the smaller. Well, the smaller is x, twice the smaller is 2x, and 10 more than that, 20 more than that, would fill out the 20 more than twice the smaller. Now I have an equation with the variable on both sides. And come to find out, this is negative 18 is equal to x. Now be careful here. We have said we were going to solve for x. When I find x, We said that x was going to be the smaller. That makes it negative 18. What number is 2 more than negative 18? Negative 18 plus 2 is negative 16. Don't be fooled, it's not negative 20. So there's also some problems that have 3 unknowns that you just have to play with. It doesn't always work to have the last one mentioned be represented by the variable, but with some practice, I'm sure you'll get more efficient at it.